Okay, so this is the video for chapter or section 2.1, types of chemical bonds. Now, I didn't get a chance to upload this onto like a white board screen, and so I won't be able to write in this video, but I think it's simple enough that we can just talk through the questions. So, the most important thing in this unit is this image right here. Now, this will be given to you in different ways. And what these numbers are basically the electronegativity numbers, also known as the Pauling scale. And the element with the highest electronegativity is in the upper right hand corner, and you kind of can tell this trend pretty easily. The lowest is here, and then the highest is all the way up here. And this makes sense because the halogens are all one electron away from having an octet, being like the noble gases, and so they so desperately want to be have their final electron, so they have the most electronegativity. And then the next most important thing is depending on the difference in electronegativity, it'll tell you if it's most likely a non-polar covalent bond, and polar means that they're opposites, positive and negative, but there's nothing here. A polar covalent bond, which is there's a somewhat negative charge and a somewhat. This sign here means that it's not entirely positive or entirely negative. Excuse me. But it is somewhat positive and somewhat negative. And here is an entirely negative and an entirely positive, and this is called an ionic bond. So if the electronegativity, now these I think are like not exact, but like a great indicator. But if it's anything greater than 2, it's an ionic bond. And if there's anything less than 2, it's most likely a polar covalent bond, unless it's less than 0.4, and then it's a non-polar covalent bond. Now let's get to the questions. Okay, question number 1. On the basis of the information opposite, which of the following arranges the binary compounds in order of increasing bond polarity? Now remember, polarity means the difference, right? It means the opposite. They have to be opposite. So you want the bond polarity to be small here, and then bigger here, and then bigger here. So the difference between carbon and hydrogen is about 0.4. So that's pretty small. And then, so this one should be bigger. The difference between silicon and chlorine is about 1.2. So that is bigger than 0.4. And then the difference between sulfur and fluoride, sulfur is 2.5 and fluoride is 4.0, is 1.5. So interestingly enough, A kind of fits. It's 0.4. And the difference between these two is 1.2 and then 1.5. And this is the less than sign, so that is true. 0.4 is less than 1.2 is less than 1.5. So A would be the right answer for question number 1. So it's really simple, just finding the difference in the electronegativity. The next question says, which of the following has the bonds arranged in order of increasing polarity? Decreasing polarity. Okay, so that means, well, this one's kind of a dead giveaway too. If you look here, this one should be greater than this one, should be greater than this one. Well, the polarity is not going to be that different between something that is the same, right? So 4.0 minus 4.0 is going to be less than these two automatically because that's 0 right here. So 0, anything here is going to be usually greater than this 0. And n, we'll have to look this up. So all you would have to do is go up here. N and F. N is 3, F is 4. You can see that right here. Now you could you could Google a Pauling scale, and there's one that I show you guys all the time. And if you want, I could upload it onto Schoology. So you have N and F, so that's 1. That's 0, 1, and then H and F is 2. So 2 is greater than 1 is greater than 0. So 2 is A as well. Okay, which of the following scientific claims about the bond in the molecular compound HF is most likely to be true? So, there is a partial charge on the HF. Now remember, HF is very, very polar, right? So H and F, what is going to be most likely true? So there is a partial negative charge on the H atom. Remember, if the difference is around 2, then there's no more partial charge. It's a whole negative charge and a whole positive charge. So it's not A. Electrons are shared equally. No, that would have been covalent. If it's around 2 and H and F we saw is greater than it, I think 2, is around 2. They're not sharing anything equally. Fluorine is much more electronegative. So it's going to pull much harder on the electron than H. It's pretty much going to have the electron. So the bond is extremely weak. That's not true. But yes, here the bond is highly polar because one is very electronegative. The other one is not very electronegative at all. And so and H is going to be straight up a positive and a negative charge. And that exactly is the definition of polar. So it'll be D. The bond is highly polar. The next question. Which of the following compounds contains both ionic and covalent bonds? So you should be looking for something that'll have an ionic and a covalent bond. So S and O, if you look at a periodic table, I don't want to exit the screen, but if you look at a periodic table, let me see if I can find one. If you look at this periodic table, S and O are both nonmetals, so that would be a covalent bond. The next one is CHOH. There's C, there's H, there's O, there's H. CHOH are all nonmetals, so they're also all covalent bonds. So you need ionic and covalent. Then you have Mg. Then you have Mg and F, and they are opposite, so that makes it ionic. Then you have H and S, which are both nonmetals. The only one that works is this one, because it is NH4Cl. So you have N, H, which are nonmetals, and Cl, which is so N and H are going to form a covalent bond, right? And then NH4, and it was going to have a positive charge, and Cl minus is going to have a negative charge, and that's going to make it ionic, because then now it has N and H has the covalent bonds, and then NH4, which it's going to end up attracting 4 hydrogens, and the Cl are going to be ionic. Okay. Next question. 2 elements form a compound. One is an alkali metal X, and the other element is a halogen Z. So off the bat, kind of know where this is going. Which of the following is the most valid scientific claim that can be made about the element? So alkali metals are in group 1. And then, so it's definitely not going to be this. So if group 1 has an extra, think about it, right? Group 1 all have 1 extra electron, and halogens all want 1 electron. So it's definitely not going to have 2 of anything. And then those things usually they're very easily dissolved in water, right? Think about NaCl. It's very easily, salt is very easily dissolved in water. And it is an ionic bond, right? That positive and that negative will make an ionic bond. So it's C. It's not sharing. Whoever is the halogen is going to have a very negative charge, and that's going to make it a polar and ionic bond. Okay, next question. The elements carbon and selenium have the same electronegativity value of 2.55. So which of the following claims can about the compound that forms from carbon and selenium, right? Selenium, Se, selenium, will most likely be true? So the difference will be 0. So the bond is not necessarily unstable. It just means that the electrons are being shared equally. B, the carbon to selenium bond is nonpolar covalent. Now, if you look, if it's 0, if you look up here, the answer was here. If you look up here, if it's 0, it is nonpolar covalent. So I thought that question was pretty easy. Next one. Of the following compounds, which is the most ionic? So now most ionic just means whichever one has a metal and a nonmetal. And the only ones here that are a metal and a nonmetal is E, because this is an alkali earth metal, and Cl, I believe, CaCl, Cl2, is a nonmetal. So nonmetals are these colors. It's a nonmetal, so it's a metal and a nonmetal. The rest of them are, these two are both nonmetals, these two are both nonmetals, these two are both nonmetals. This is a nonmetal, and this is a metalloid. Si is a metalloid. It is a metalloid, Si. So that one has to be a metal and a nonmetal. So look, these are nonmetals, these are metals. Green, this color is a metalloid. So that one doesn't work. Last question, which one is least polar? Another way to figure this out is by seeing the differences, by the way. Least polar, you just take all of these values and you subtract. So here, let's go. NH, FH, OF, IF, and OH. So again, I told you that this was going to be the most useful thing right here. So now you could figure it out based on the relation. Excuse the announcement. Sorry about the announcement. If you're not prepared, please bring it with you. Retake is Monday, November 25th. Please mark your calendar and come prepared. Senior due payment plans are available for class of 2026. Please use the reference for more information. Senior pictures will be November 19th to the 20th. Okay, back. Anyways, hydrogen here is 2.1, right? And the examples were NH, which is a difference of about 1. HF, which is a difference about 2. So automatically, is it asking for? Let me see really quickly. Is it asking for the most or the least? Least polar. So you want the numbers to be as close as possible, actually. So, okay. So remember when we did fluorine, those would have been the least. So the difference, so actually, we're off to a good start with NH. NH is a difference about 0.9. And then HF is a bigger difference of 1.9. But then OF is only a difference of 0.5,
Any questions about the chapter?
right? And then IF is a difference of 1.5, and then OH is a difference of 1.4. So the answer would be OF. So I would go down here, and I would pick answer C. So OF had the smallest difference, which was 0.5. That's all.